Hey everyone, welcome back. Today, we're going to be taking a deep dive into the surprisingly fascinating world of software testing.
Oh, yeah. It's way more exciting than you think.
Yeah, I mean, everyone uses software like constantly, but no
Yeah.
one really thinks about like what goes on.
Behind the scenes?
Yeah, behind the scenes to make sure
yeah.
that it actually works, you know?
Exactly.
So we're going to be using this document called testavimas.pdf as our guide. And it's going to walk us through a few key software testing techniques that are used.
Yeah, the ones they use every day.
To ensure that the software we use like actually does what it's supposed to and hopefully does, you know.
Yeah, crash. Or do weird, unpredictable things.
Right, exactly.
Which is super frustrating.
Yeah, no one likes that. So
Let's dive in.
Yeah, let's dive in. So the document focuses on three main techniques: equivalence partitioning,
Right.
boundary value analysis, and extreme value analysis.
All very important.
Yeah, so let's start with the first one, equivalence partitioning. What is that all about?
Well, imagine you're baking a giant batch of cookies, right?
Yeah.
And you want to make sure they all taste good. You wouldn't taste every single one, would you?
No, definitely not. I'd be sick.
You would strategically choose a few.
Right.
That represent different parts of the batch. And that's the basic idea behind equivalence partitioning. Instead of testing every single possible input, you divide the inputs into these groups called equivalence classes.
Okay.
And then you test one from each class.
So like representative cookies from the batch.
Exactly.
Got it. And the document gives a code example to kind of show this in practice. It talks about like a program that categorizes people based on age.
Right, like under 12 as a child, 13 to 17 as a teenager, and then over 18 you're an adult.
Right. So with this equivalence partitioning, you just pick like one age from each of those categories.
Right, like 10, 15, and 20.
Yeah, okay.
To make sure that the code is actually categorizing them correctly.
Oh, okay, that makes sense. But it sounds like equivalence partitioning like isn't totally foolproof.
You're right. It can sometimes miss errors.
Okay.
Because it doesn't test every single input.
Yeah.
So that's where boundary value analysis comes in.
Okay, so boundary value analysis, that's like...
That's the second technique.
Yeah, what is that?
This focuses on the edges of those equivalence classes, so the boundaries.
Okay, so like going back to the age example.
Exactly.
It would be like testing the ages like right at those cutoffs.
Yes. Like 12, 13, 17, and 18.
Yeah, because those are the ages where like...
It switches from one category to another.
Right, like that's where...
And that's where errors can sometimes sneak in.
It could potentially mess up.
Yeah.
Okay, and I actually noticed that the document, it points out a potential flaw in that age code example.
Oh, right.
It says something about a 12-year-old.
Yeah, being categorized incorrectly.
Yeah.
Yeah, equivalence partitioning might have missed that.
Right, because it wouldn't have tested the exact age of 12.
Exactly, but boundary value analysis would catch it.
Because it would have tested 12. Got it. Okay. So it seems like, you know, equivalence partitioning, boundary value analysis, they kind of work together.
Yeah, they complement each other.
Yeah, but what about when you want to like really push the software to its limits and see what happens?
Well, that's where extreme value analysis comes in.
Okay, yeah, extreme value analysis, that's the third one.
Mm-hmm.
What's that?
So this is all about testing with unusually large or small or sensitive inputs.
Oh, so like typing in a really, really, really long number.
Exactly. Or a negative number when it should be positive.
Yeah, or like 0.
Yeah, or 0.
When it can't be 0.
Exactly.
Yeah.
And the document actually has a really good example of this.
Okay.
They talk about a program that solves quadratic equations.
Oh, okay.
And if you don't test with those extreme values,
Okay.
the program could like crash, give you a wrong answer, or even create a security vulnerability.
Wait, really? A math program could be a security risk?
It sounds crazy, but yeah, if it doesn't handle those edge cases correctly, it can lead to some unexpected problems.
Mm-hmm. Wow, okay. And speaking of interesting examples, the document also brings up this idea of test-driven development, which I've heard of, but I don't really understand.
Oh yeah, it's a super interesting concept.
Yeah.
So TDD is basically where you write the tests before you write the actual code.
Really?
Yeah, it's kind of like you're setting a goal for your code.
Okay.
And then you write the code to meet that goal.
Okay, so it's kind of like having a blueprint before you start building a house.
Perfect analogy.
Oh.
And the document uses that same quadratic equation solver example to explain how it works.
Okay.
So imagine you're building this function called calculate roots
Mm-hmm.
that figures out the roots of an equation. In TDD, you would first write a test for one specific behavior.
Okay.
You want that function to have, like, let's say we want to check if it can handle an equation with 2 distinct real roots.
Okay, so just starting with like one specific scenario.
Right, exactly. Not trying to solve everything at once.
Okay.
And the document actually shows like a little code snippet of how you might do this in Python. You'd write a little test function.
Okay.
Let's call it test calculate roots.
Okay.
And inside that function, you would call our yet to be written calculate roots function.
Okay.
And you would give it coefficients that, should produce those two distinct roots.
Okay, so we're like setting up a little mini math problem within the test.
Exactly.
But wouldn't the test like immediately fail since the calculate roots function doesn't even exist yet?
You got it. That's the key part of TDD.
Okay.
The first test should always fail.
Okay.
It confirms that our test is working.
It's kind of like if you're testing a smoke detector, you want to make sure that the alarm actually goes off.
Right.
When there's
Exactly. A test that always passes is useless.
Right.
So once we confirm that our test fails, then we actually have to write the code for the calculate roots function.
To make it pass.
Yes, to make that first test pass.
But just to handle that one specific scenario, right?
Exactly. We wouldn't worry about like all the other cases yet, just that initial test.
Okay, so we're kind of taking it like step by step.
Yeah, baby steps.
Okay, and then once that first test passes, we would like add another one.
Right, exactly. Maybe for an equation with only one root.
And then that would fail.
And then you write more code.
And then you fix it.
And then you just keep adding more tests.
Okay.
Gradually expanding what your code can do.
So this whole process is called test-driven development?
Exactly. You're driving the development with the tests.
Okay, cool.
It seems like TDD is not just about, making sure the function works, but also about like thinking through all the ways it could go wrong.
Right, and catching those errors early on.
Okay.
And the cool thing is this approach leads to code that's not only more reliable, but also better structured because you're breaking it down into these smaller testable pieces.
Okay, so it's easier to like understand and change later on.
Exactly. And it gives developers this confidence that their code actually works.
Okay, but isn't there a danger of like being too confident?
That's a good point. But TDD actually addresses that because every time you make a change, you rerun all of your tests.
Okay.
To make sure nothing broke.
So it's like this constant feedback loop.
Exactly. It's like a safety net.
Okay. And it also kind of ties back to that idea of trust that we were talking about earlier.
Yeah. If developers are confident in their code because it's been thoroughly tested, then users can be more confident too.
Right. Because we all want software that just works, Exactly. And the document makes a really good point that these testing techniques aren't just theoretical. They have real-world consequences.
Right.
Like, remember that quadratic equation solver?
Yeah.
If it didn't handle extreme values correctly, it could have created a security vulnerability.
Oh, wow.
Yeah. And that could lead to like a data breach or worse.
So testing isn't just about convenience. It's about safety and security too.
Exactly.
Yeah.
And, all of this ultimately comes down to user experience.
Okay.
Think about it when software is well tested, we as users, we can kind of relax and trust that it's going to work the way it's supposed to.
Yeah, it's like, knowing that the bridge you're driving over has been like thoroughly inspected and is safe.
Exactly. It just gives you that peace of mind.
Right. So it sounds like, good software testing is really about so much more than just like finding and fixing bugs. It's about building trust. It's about, ensuring safety and security. And it's ultimately about like creating a better experience for everyone.
Absolutely. And the document actually, it makes a point of saying that, this isn't just like a one-time thing.
What do you mean?
Well, software is always changing, right?
Right.
They're adding new features, updating old ones, and like technology in general is always evolving.
Right.
The testing has to be this like ongoing process.
So it's kind of like a never-ending game of cat and mouse.
Exactly.
Between like the testers and the bugs.
Yeah.
Okay, so I guess this begs the question, like, what does this all mean for us, the people who don't actually write code?
Right.
Like, should we all go out and learn how to, like, write test cases?
Well, while it's definitely helpful to understand the basics,
Okay.
I think the biggest takeaway for non-programmers is to just be more mindful.
Okay.
Like, be more observant when you're using software.
You mean, like, pay attention to those moments when things aren't working quite right?
Exactly. Don't just, like, blindly accept it.
Oh, okay.
Be curious.
Okay.
Ask questions, and don't be afraid to report bugs or, provide feedback to the developers.
So it's kind of about being like an active participant in the digital world?
Exactly.
Rather than just a passive consumer?
Yes.
Okay. I like that. It makes me feel empowered.
Yeah.
To like advocate for better software.
And I think the more we all understand about like what actually goes into making software reliable,
right,
the more we can appreciate, those times when things do work flawlessly.
Right, because it's not magic.
It's not magic. No.
There are people behind the scenes.
Lots of hard work.
Making it happen.
Exactly.
Yeah. So I guess To all the software testers out there, thank you
Big thanks.
for making our digital lives a little less buggy
Yes,
and a lot more enjoyable.
absolutely.
So that's it for today's deep dive into the world of software testing.
That was fun.
Yeah, it was actually pretty interesting.
Yeah,
We hope you learned something new.
definitely.
And yeah, until next time, keep exploring, keep learning,
Testing.
and keep diving deep.
See ya.
See you in the next deep dive.